Howdy folks, we're going to go over project 2 here. So this is the vehicle, electric vehicle, and internal combustion engine vehicle classes. So I started up just a blank project here for project 2, and the big difference here is we're not going to do anything here in this main class with the main method. Right? We're not going to do anything with user input. We're not going to have any sort of output at all. We're only writing the classes, and then we're going to write unit tests to make sure that the classes do what they're supposed to do instead of doing that in main and checking it ourselves, because computers are much better at it than we are. So I'm going to come to my source package, and I'm going to add a new Java class. So we'll start with vehicle. The vehicle had a couple attributes, right? So it had a private string for make. Let me zoom that in a little bit, sorry. It had a private string for model. It had a private string model, a private string for color, and then it had a private int for odometer. Right? So we have a make, a model, color of the vehicle, and then the odometer value here. Our constructor should accept all arguments except odometer and default that to 0. Okay, so we could write it ourselves if we want, or we could let IntelliJ do it for us here. So I'm going to just generate a constructor. I'm going to check all these, or control click to highlight all of them here, and say great. And then I'll set my odometer value. Probably do this in the right order here. My odometer value to 0. Right, so now I have my constructor. Right, you give me the make, model, and color. I've got this one here. Then we want to have get methods for all of our attributes. Sure, so we'll add get methods for all the attributes. So we'll go generate. Again, you can write them yourself if you want here, but I prefer not to. We'll just let them generate. So this will give access to these attributes to people using my class here. Then we're going to include a set method for the attributes of a car that can change, in addition to this drive thing. So what can change when it comes to our vehicle here? Well, once it's a Chevy Bolt, it's always a Chevy Bolt here. But just because it's gray doesn't mean it's always gray, right? You can go paint your car. So I think it makes sense to be able to set the color of a car here. So we'll just go add a set method for color, right? We'll go and generate our set method for color, and we're set here. Right? The make doesn't change, the model doesn't change. Now the odometer doesn't set, right? You don't go up to your car and say, hey, your odometer reading, I know it says 85,000 miles, but I'm going to just, crank that back a little bit and say 30,000 miles and then go sell it. But you can't just set the odometer. So it doesn't make sense to have a set odometer method. The way that we interact with that odometer value is that we have this method for drive that says, hey, you tell me how many kilometers you're going to drive, and we'll increase the odometer value by the kilometers driven, and we'll return a Boolean value of true. Now, the true doesn't make a whole lot of sense for vehicle, but it'll make sense in the next couple classes here. So then we'll write a method for drive. Now, this one we have to write ourselves because it's not a set or a get method. So we'll have a public Boolean for drive given an integer for kilometers to drive. Kilometers to drive. And we'll take my odometer, and we're going to add to it the kilometers to drive, and I'll return true. Life is good. Now, it probably would be nice to add some sanity checking here, that we're only going to do this if kilometers to drive is a positive value, right? Like driving backwards is still considered driving. You can't rewind this sort of thing here. So I might add that in. I'm not expecting it of you folks at all, but I'm going to say, hey, if it's greater than 0, let's go add this here. And again, I might just return true anyway. Where's my format? Oh my goodness, code, reformat, Control-Alt-L. Control-Alt-L, there. Control-Alt-L, there it goes. I was hitting shift instead of control. So, sure, it might be nice to return a false if you give me negative, but again, this is more than we were asking for anyway. So I think this is fine for drive. Okay, and that's my vehicle class. That was it. So now we can write some tests for it, right? Well, what do we need to test? So generally, I don't test the get method separately because that's a big waste of time. I'll test the constructor and the gets at the same time. Then we can test set color and we can test drive. Okay, so in terms of code coverage, this idea of is my code actually running as I'm testing it? Well, there's only one path here where the odometer changes. So if I give it a positive value, it changes. Now, it might be nice to also test, hey, if I give it a negative value, it doesn't change. But in terms of code coverage, all of the lines of code are running in my test. So I'm not too particular one way or the other. I'm going to go to test here. So I don't have any tests. Yes, let's make some tests. Yes, please. Vehicle test. I want to test the set color. I want to test drive. And we'll come back for our own constructor here in a minute. And then it's going to be upset with me because I don't have JUnit loaded yet. That's fine. Click the little light bulb and say, hey, I want to add JUnit 5 to the class path here. Yes, let's go add it. So what that means is it's going to go download this JUnit stuff for you. IntelliJ is really nice and handy for that sort of thing. So it actually goes and adds it to this like external libraries thing here. You can go manually do it, but it's a bit of a pain. So it's really nice to let the tool do it for you. So I have set color, I have drive, and we're also going to add one more for my test constructor. This is our vehicle constructor. Okay, so we'll do the vehicle constructor first. We're going to arrange, we're going to act, and we're going to assert. Right? These three sections. It's just a convention. You don't have to do it this way, but this is a nice way to lay things out, and it's a pretty common practice in the industry. So I'm going to have, what are my expected values when I make a new vehicle? Well, I'll have a string for the expected make. I'm just going to say make, right? The name doesn't actually matter here. I'll have a string for the expected model is model, and a string for the expected color is color. I mean, you could use any sort of values you wanted here. The values themselves don't matter. And then an int for the expected odometer. Odometer is 0. So these are the values I expect to have when I actually run the code. So in my act section, what am I doing? Well, I'm going to make a vehicle. So I'll say, hey, this is a type of vehicle here. I'm going to call it probably just lowercase vehicle equals a new vehicle. This will call the constructor, and I'll give it the expected make, I'll give it the expected model, and I'll give it the expected color. Okay, so I've called the constructor. We're going to save it in this variable as lowercase v vehicle. Then we'll go get the actual value. So I'll have a string for the actual make is my vehicle.getMake. Right, call this make method, see what does this vehicle think its make is. What is that string for make that I'm going to get here? I'll get an actual model, I'll get an actual color, and we'll get an actual odometer. So we'll have model, we'll have actual color, we'll have actual odometer. I think some people actually use the double for this, which probably makes more sense than an integer. I don't think I specified what it would be. So let's go back and make that a double, because I think that actually works better here. Because you can drive like fractions of kilometers, right? So we'll go back. My vehicle will make that a double. Now it's going to be upset a couple places. That's okay. In my get odometer here, I'm going to return it as a double. That should be fine. Okay, vehicle test. Now it's get make. Now I want get model. I want to get color, and I want to get odometer. So vehicle dot, and I'll get my get model, my vehicle dot get color, my vehicle dot get odometer. Okay, so now I have my actual values here. Okay, and I'm going to assert, do they equal? Right, so I can assert equal here, and I'll say, hey, the expected first, my expected make, does that equal the expected or the actual make? Oh my goodness, that type ahead was not helpful. The actual make. Right, do they equal? We're just going to assert for all four of these things here. Right, the actual model, the actual color, and the actual odometer being the actual here. I'm just doing the double click to highlight the whole word and then Control-C copy, because that makes my life a little easier here. Okay, and that's it. Do these things match? So if I make a new vehicle, do I get the values that I expect to get that I gave it back out? And does it default to 0 for the odometer here? So we can run that test here, and we should get a green check mark. Let's give it a look. There it goes. It passes. So all these asserts passed. So for color here, I only care about the color. So I'm going to have an expected color here. So I'm going to have my string for expected color equals, we'll just say color here. And then I'm going to make a vehicle. Again, so this is arrange here. Now, I'm not testing the vehicle constructor. So I'm going to make the vehicle here equals a new vehicle. Now, I don't care about the make, so I'm just going to leave it empty. I don't care about the model. I'm going to leave it empty. And I want the color to not be the word color to start. Right? So then I'm going to call my set color, right? Vehicle set color, given the expected color. Can I give it a color and have it change from something to something else? I'll have my string for the actual color equals my vehicle.getColor. And then I can assert equals, does the color equal the color? My expected color equal the actual color. Okay, same idea now with my drive test here. I'm going to have a double for my expected odometer. We'll just say it is, 42. And okay, so drive probably then should take a double here, right? If we're going to add specific number of kilometers, we could probably do the double and be very precise here. So you can drive fractions of kilometers rather than whole kilometers. That probably makes sense here. Odometer. There we go. So that's my range. Now my act, I'm going to call vehicle.drive, the expected odometer amount of kilometers to drive. And then I'll have a double for my actual odometer is my vehicle.getOdometer. Okay, and then I can assert, do they match? So I'll just come back and copy paste this line here. Do they match? Right, so if I drive, it does this. Now, I could also check the drive returns a true, and maybe that's nice here. So maybe I'll have a Boolean for the result here is my vehicle drive. And then for result here, you could say does true equal true, but there's also this assert true to just save you a little bit of time here, this result. Or maybe drive result, and you could call it anything you want here. So we'll say, hey, I got back a true, and my odometer now reads 42. Okay, so let's give those a run here. So I'll just come back and run them all. Not a breakpoint, not a breakpoint. Run the tests. And I should get 3 passes here if things worked out well. All right, we get 3 passes. So vehicle is pretty set. So now we're going to come back and we're going to take the internal combustion engine vehicle, extend vehicle, and a electric vehicle, extend vehicle. Now, both of these are actually basically the same thing with different attributes, right? They both just concern themselves with fuel. What is the fuel that gets you the distance you want to go? So for the internal combustion engine, it's kilometers per liter, the max liters in tank, and the current liters in tank. We'll have a constructor that accepts arguments for all our attributes except the current liter, default that to 0. We'll have get methods for the new attributes. We'll add a add gas method that accepts a liters of gas. Make sure we don't go above the max. Right? If you try and add 1,000 liters of gas and your tank only holds 100, you can't put 1,000 liters in the tank. So the tank will stay at 100 and you've just spilled gas all over the place and done a bad thing. But as far as the vehicle is concerned, it's at full. And then we're going to override the drive method and change the behavior. We're going to add some special behavior here to reduce the amount of gas in the tank by how much gas we need to drive the number of kilometers. If there's enough gas, we return true. If there's not enough, don't let the tank go below 0. Like set it to 0. Hey, you ran out of gas, and give them back a false. Now, not everyone was necessarily setting it to 0. They would just say false, and that's fine too. So either route you went with that was going to be okay. Not too concerned here. So that's our internal combustion engine vehicle. So we need to go add a new class. So I'm going to go new Java class, internal combustion engine vehicle, and then we add the extends keyword. This extends vehicle. Let me zoom that in a little bit here. Sorry. Now, right off the bat, that gets upset here because we don't have a constructor here. Right? So the error that it's telling me here is there's no default constructor available in vehicle. You can't make a vehicle without giving it make, model, and color. So if internal combustion engine is a vehicle, you can't make an internal combustion engine vehicle without making a vehicle with the constructor. So the first thing we want to do is we want to add our constructor here, and the generate method is really good at this. We can generate a constructor, and it gives me the one that just takes all my attributes that my superclass needs, my vehicle class needs. Now we also want some other ones here. Oh my goodness, I misspelled that. Internal. I misspelled it here too. Okay, so refactor, rename. I did that wrong. Internal combustion. Sorry about that. Refactor. Okay, because the name of the class needs to match the name of the Java file. Java is very particular about this sort of thing. Now, other attributes. I don't actually want this constructor yet because I need to add these attributes. So we need to have attributes for some of these things. Now, these are going to be private. These are probably doubles here as well. Now, you could list them like this. I'm not a fan of this syntax at all, listing them all at once here. I really prefer these on their own line, really for no good reason. Like, they're perfectly legitimate to do it this way. I don't like it. And that's all. That's really the entire reason. I just don't like it. So I'll just make them all on their own line because that makes me happy. Okay, now we can make a constructor. And we want kilometers per liter and max liters. We don't care about the current liter. We're going to say every time you make a new internal combustion engine vehicle, it starts with an empty tank. Right, so we just bring this down a line here. Nope. Oh my goodness. Okay, it really wants to stay tabbed in. That's kind of annoying, but that's fine. And then we'll set our current liters in tank to 0. So you tell me how many kilometers you get per liter. You tell me the max liters in your tank. Right, what's your tank capacity here? And then we'll start you off at 0. And then this super call here, remember this will call the superclass constructor. You have to do this first in a constructor that's calling a superclass constructor. Because an internal combustion engine vehicle is a vehicle, it has to call the vehicle constructor so the vehicle constructor runs. Right? Only if you have one that has parameters. If you have one that doesn't take parameters or a no argument constructor or a default constructor, that can just run, no problem. But if the only constructor you have takes arguments, you have to use it. That's why we're calling this one here. Okay, so then we need to add some get methods for all of our attributes here. So we'll go generate some get methods for all of our attributes so we can get the current value. Now, we're not needing to change any of these here. We don't need set methods for those things here. But we do need add gas, we need drive, right? Now, I know your kilometers per liter does change realistically depending on how you drive, maybe even if you're using your air conditioning or not. We're just pretending that doesn't happen because it makes life easier to pretend that doesn't happen for us. Okay, so what we do need though is we need drive and add gas. So public void add gas, given a double for liters of gas to add. Right, we're going to take our liters, current liters in the tank, we're going to add the liters of gas to add, and then we're going to say, hey, if we went over the max here, is greater than my max, set it to the max. Current equals the max. Right. We overfilled the tank, and the rest spilled on the ground. But as far as our tank is concerned, we're in good shape. Now, the idea here, right, is we're protecting the integrity of our class because the drive method will use the current liters in our tank. So if somehow you manage to tell our vehicle class that it has 10,000 liters, it's going to think we can drive all the way to California without stopping for gas. That probably won't happen. Right, so we need to put some bounds around what are good values here. And really, you tell me what the size of your tank is, because each vehicle is going to be a little bit different. We don't have a standard tank size. Okay, so we can add gas. So the add gas didn't have to return anything here. It just doesn't go over the max. Again, it's probably a good idea to make sure we don't go negative as well. Right, so probably if my liters of gas to add is greater than 0, then we can go add it. Okay, just to make sure you're not like subtracting gas somehow by giving me a negative value. Now, in terms of code coverage, when we test add gas, if we don't try and overfill, this line of code never runs. So to get all of these lines of code to run, we just need to give it a value that will end current above max and make sure we end at max. All of the lines of code will run. Now, it might be nice to do some of those other checks and say, hey, if I give a negative, nothing changes. If I just give it regular, it works. But in terms of code coverage, we don't need it. So this is fine like it is here. Okay, and then drive. So public boolean drive, and I'm going to add this override tag here because it makes life easier for me at override, because it's going to check to make sure I do the right thing here. So if I forget to add the arguments here, it's going to say, hey, method does not override methods from its superclass. Oh, I didn't do something right. It doesn't match. But if I have a double for kilometers to drive here, now it matches, right? The name of the method matches and the arguments match and the return type matches. Now I'm okay overriding it here. Okay, so if I want to drive so many kilometers, I need to see, do I have enough gas here? So I'm going to have a double for gas, liters of gas required is going to be my kilometers to drive divided by my kilometers per liter. Right? If I get 10 kilometers per liter and I want to drive 20 kilometers, that should take me 2 liters of gas. That's just how the arithmetic works, right? So then I can see, hey, if my liters of gas required is greater than the current liters in the tank, I'm going to return a false. Right? Bad things happen, you can't do that. Now, we could run them out of gas here if we wanted to, or just tell them we can't do it. Either way was okay with you. It was okay with me, right? It just says, don't let the gas in the tank go below 0. Return a false result. So make sure it doesn't go negative. If you just subtract the amount that you calculated, if you just say, hey, take my current liters, subtract this from it, life is good, you're going to you could end up with a negative value of gas in your tank, which is completely invalid. You can't have negative gas in the tank, right? That's wrong. Just isn't going to happen. So sure, this prevents that from happening. So if you went a distance, fine. If you didn't go a distance, that's okay. Either way here, you had an option. So I'm just going to say, we're just going to tell you no. This is no good here, right? So like you plug in a route in your GPS and you say, I want to drive here. It tells you no, you can't get that far. Add a stop for a gas station or something like that. However this class is going to be used. So if this doesn't happen, then Then I can take my current liters in the tank and I can subtract from it the liters of gas required. Now, here's the tricky part though, because the odometer hasn't changed, right? And I can't change the odometer itself. I don't have access to it because it's private in my superclass, right? Because I need to say, hey, I drove a bunch of kilometers, I should increase the odometer here. Because if you can drive this car and the odometer doesn't move, you're gonna be able to sell this car for a lot more money than it actually is probably worth, right? So I need to ask my superclass to do its drive thing, given my kilometers to drive. Then I can return true, right? So this makes sure makes the odometer value increase, right? Because that's what my superclass does. I don't have access to that inside this class, so I still want to do what my superclass is doing in my special version, but I want to do additional other things and say, hey, if I don't have enough gas, don't move the odometer. I told you no, you can't drive that far, right? So now in terms of code coverage, this line of code only runs if we try and drive too far. So we're going to have at least two tests, right? One test for this, one test for this. So if I give it a too far of a distance, I should get back a false result and the odometer shouldn't change. And my gas shouldn't change. If I give it a distance that I can drive, I have enough gas for, the gas should change, the odometer should change, and I should get a true result. So that's it for the internal combustion engine vehicle test. So let's add some tests. We'll go to test. Nope, that was wrong. Go to test here. Click the wrong one. I got excited. We'll make some new tests here. I want to test add gas, and I want to test drive. We'll test the constructor as well. So we're also going to test the constructor. Test for constructor. This is, I don't know, ICE constructor vehicle. All right, I'm usually I don't like acronyms, so that's my internal combustion engine vehicle constructor test. Combustion. There we go. Sure, that wasn't too bad to type it all out, right? Wasn't too bad at all. Okay. Now let's test the constructor. So we're going to arrange. We're going to act. We're going to assert. My expected values. So I'm going to have a double for the expected. And now I have a bunch of these things here, right? Kilometers per liter. I'll just paste them over here, right? Double, double, double. And I'll just put the word expected in front of each of these here. And then add some capital letters. Right? Okay, what should they be? Well, we'll say, I don't know, 10. And then how about 5? And then how much should be in the tank when I make a new vehicle? 0. Okay, now we'll make a new vehicle. So I'll make an internal combustion engine vehicle. We'll just call it vehicle, the new internal combustion engine vehicle, given an empty make. We don't care about the make. We don't care about the model. We don't care about the color. Now, what values does it want here? Let me bump this down a little bit here. My goodness, it's still really long. Now I think it wants the expected kilometers per liter. It wants the expected max liters in the tank. Right? Does that sound right? So if we look at our constructor here, it needed values for kilometers per liter, max liters in tank, after the other things. Kilometers per liter, max liters in tank. Awesome. Now we'll get our actuals. So again, we'll get a bunch of actuals here for doubles. Let's change this word here to actual. Change that, change that, change that, and we'll ask the vehicle, hey, what is your get kilometers per liter? Vehicle, what is your get max liters in tank? Vehicle, what is your get current liters in tank? Right, and then we'll assert the equal. We'll assert equals here. My expected kilometers per liter and my actual kilometers per liter. Again, copy paste, do some other copy paste. Actual in the tank, current, actual current in the tank, expected max, actual current, or expected current. Right, let's give it a try. Does the constructor give me the values back that I expect? Excuse me. All right, that one worked. Now for add gas, right, we said we only really need one method for one test for add gas, because all of the code will run if we go over max. So sure. So in my internal combustion engine vehicle test, what I care about then is the max liters in tank. So I'm going to have a double for the expected current liters in tank. We'll say it's 10 here. Sure. And then we'll make an internal combustion engine vehicle. Vehicle equals a new internal combustion engine vehicle. I don't care about the make. I don't care about the model. I don't care about the color. I don't care about the kilometers per liter. I do care about the max tank size. So the max tank size should be my expected liters in the tank. right? Semicolon. Okay, so I arranged. Now I'm going to add some gas. So we'll call my vehicle, we'll say add gas. How much do I want to add? I want to add the expected liters in tank. How about times 2? We'll just double it, but it should still stop at the max here, which is what I'm expecting. So as long as I'm going over, right, I know this line of code will run, because if it doesn't go over, this line of code doesn't run. Right, that's all. So we just want to make sure we're going over that number here. So we're going to go over, and I'll have a actual liters in tank here. Is my vehicle dot get current liters in tank. This is my actual, and I'll just go copy paste that line. Does my current match my actual? My expected match my actual? Okay. Now for drive, this will be, I don't know, how about returns true or something? Returns true, and then we'll have another test for drive that returns false, right? Because we want to test both of those paths to make sure that this line of code runs and these lines of code run for drive. Okay, so I need a vehicle, and I'm going to have a couple things here for the vehicle. So if it works here, I'm going to have an expected current liters in tank, right? And I'll also have a double for, this will be my kilometers per liter here. Now I'm going to make this easy and just say I get 10 kilometers per liter. Okay, so when I create my internal combustion engine vehicle, I'll give it my kilometers per liter, and my max tank size we'll say is 10. That's fine, no problem here. Okay. No, actually, no, I'm sorry. So I want to have a different max. So I want to have a double for my max liters in tank. We'll say maybe that'll start at something higher, and we'll go down a couple, right? So we'll say, hey, the max is 10. So I can fill it up to the max, and then if I drive enough, I'll get back to this value here. So still in my range, I need to add gas. I'm going to take my vehicle, I'm going to add some gas here, I'm going to add my max. We'll just fill it all the way up to the top, right? Because it starts empty, fill it up here. Then now what we're testing here is drive. So I'll have a Boolean for my result is going to equal my vehicle.drive. Now, how far do I want to drive? So if I start with 10 liters and I expect to get down to, let's just say 9 here, make this easy, and I get to 10 kilometers per liter. Well, if I go 10 kilometers, it should take 1 liter of gas. I should be down to 9. So let's drive 10 kilometers. That should return to true, and then I'll have an actual current liters in tank here. Right, so we'll get a double for my actual liters in tank. Is going to be my vehicle get current liters in tank. Let's see, what does the vehicle think now after we've driven 10 kilometers? And then I'll have a double for the expected odometer as well. Should also be 10. So that's right. So we want to drive. That's right. We want to drive the expected odometer value here. There we go. A double for the actual odometer. Actual odometer is my vehicle.get odometer. Right? Because those three things should happen. I should have less gas, I should have the odometer increase, and I should get back a true result. So then we can assert true here, given my result, and then we can assert equals my expected odometer and the actual odometer, and I can assert equals my expected current liters in tank and the actual current liters in tank. So if it worked, they should all match, right? Let's give it a try. All right, that returns true is good. So now for our returns false here, basically the same thing, but I want to drive way further here. So if I can't drive at all, I should stay at max, right? Shouldn't have changed, right? Now my odometer should stay at 0 because it didn't work here. So if I want to drive, so I want so much more than I can actually go here. So we'll just put like, I don't know, a really big number here. I can't drive that far. I should get back a false result. So I can assert false. My current odometer is the actual odometer, should still be 0, and my current liters in tank should be 10. It shouldn't have changed at all here. Right? And again, this kind of depends. If you used up all the gas, fine, but that's no problem here. It gets a little trickier because if you used up all the gas, you should have driven that amount of distance. So you should have changed the odometer by as far as you could have gotten based on your current amount of gas in the tank. So that's fine. Right, so here's our internal combustion engine vehicle. Right, okay so far? So our electric vehicle is actually the exact same thing here, except it has kilometers per kilowatt hour, max kilowatt in battery, and current kilowatt hours in battery, and then you charge it, you don't add gas. Drive still does the exact same thing, but it's a slightly different arithmetic here. Okay, so I'm going to cheat here a little bit, and I'm just going to copy this whole class here. I'm going to add a new Java class. We'll call it electric vehicle, and I'm going to copy paste in on top of it here, and we'll go back and change it back to electric vehicle. Electric vehicle here, vehicle, electric vehicle, electric vehicle. Now we get a couple different attributes now, right? So we have some different names of our attributes. We have kilometers per kilowatt hour, max kilowatts in battery, and current kilowatts in battery. This should have been hours. I'm sorry, I missed the word there here. So kilometers per kilowatt hour, max kilowatt hours in battery is probably more accurate, and then current kilowatt hours in battery, again, is probably more accurate here. Okay, so then we can just change these values here. And then we'll say our current is 0, just like the other one, right? Kilometers per kilowatt hour, max kilowatt hours in battery, and current kilowatt hour starts at 0. Now we can just change those get methods. We'll just whack all of those ones here. We don't need the, we'll leave that for a minute. We'll go back and add that for charge. We'll generate some gets here for those. Sure. Now this is charge, and this is kilowatt hours to charge. Kilowatt hours to charge here. Sure, why not? So we'll say, hey, if that is positive, we'll take our current kilowatt hours of the battery, we'll add the amount to charge, and if our current went over the max here, then we'll set current back to the max. Nope, that's the wrong one here. Current kilowatt hours. There we go. Sorry, bad copy paste. So if we want to charge a positive amount, add it. If the current amount went over the max, pretend it didn't happen. Set it back to the max. Okay. Drive given a kilometers to drive just changes here now to my kilometers per kilowatt hour, and this is my kilowatt hours required. Kilowatt hours required. So if my kilowatt hours required is greater than the current kilowatt hours in the battery, return false. Otherwise, take my current kilowatt hours, subtract the kilowatt hours required, drive the kilometers to drive, return true. Everything else was the same, right? So basically the same class. Now we'll go write some tests. Go to test, create a test here. Sure, we want test for charge, we want test for drive. We'll add the test for constructor in a minute here. So it's basically the same as our other tests over here, our internal combustion engine tests. Here we go. So our drive returns true, returns false. Should be the same thing here for electric vehicle test. Except now we don't want an internal combustion engine vehicle, we want an electric vehicle. Equals an electric vehicle. And these values will be just a little different here in a second, right? We're not adding gas, we're charging. So we'll have charge. Now it's not max liters in tanks. I'm going to right click and say refactor rename. This will be max kilowatt hours in battery. Now that refactor rename lets me rename it here and not have to copy paste. That's my favorite little shortcut here. So you right click and say refactor rename. This is not kilometers per liter, it is kilometers per kilowatt hour. Now expected liters in tank, no, this is going to be refactor rename. Expected current kilowatt hours in battery. Battery, right? Cool. And now it's not the actual current liters in tank, it's the actual current kilowatt hours in the battery is my get current kilowatt hours in the battery. So when I'm asserting here, right, I'll have my actual current kilowatt hours and the actual expected current kilowatt hours. Odometer stays the same. So just some copy paste here. Nothing too bad. So I did all the copy pastes here. I'm just going to do them over here again. That should be fine. So we should stay at 10 kilowatt hours. I'm going to go charge it up to the max. Sure, we're going to go drive it a really big number here. We should assert false. And then they should match, right? Nothing should have changed otherwise. Odometer should be 0, right? That's right. So let's give it a try for those ones here. Run the tests. All right, tests are good so far. Now charge passes, but it's empty here, which is weird, but that's okay. So if I'm going to go charge an electric vehicle here, I should be able to go do some of this stuff here. Excuse me. So I should have an expected current kilowatt hours of battery. Should be at the max here. We don't care about the kilometers per kilowatt hour. We care about the max here, right? Well, really the max should just be that value here, which will make life easy for us here. We don't have an expected odometer. We don't care about the kilometers per kilowatt hour. And we're going to charge it then to the max. Oops, I hit my insert key. Max times 2, right? Because we want to go over the max to make sure it stops. And then we'll go get the actual current kilowatt hours in the battery, right? So charge is what we're testing here. That's in our arrange, or we've arranged, and we're acting, and then we'll go assert that they match. Assert that they equal here. Okay, so now we tested charge. Let's give that a shot. The last thing to do then is add our test for constructor here. So add test for void electric vehicle constructor here. Right, we need electric. Man, spelling is hard here. Sorry. We need to make a vehicle, and we care about a couple of these values here. This is probably a couple of these ones will do for us here. So we make a new vehicle. We don't have an odometer. The current should be 0 on a brand new vehicle, and we'll say, how about, I don't know, 5 and 10? Why not? So we'll go give it the current, or the kilometers per kilowatt hour. We'll give it the max, and then we'll go get the actual values out. So I think I have a couple of these gets already, right? We'll get the current out here. So after we make our vehicle, we can get the current kilowatt hours. We'll get a double for these ones here. My actual and my actual here. So we'll say my vehicle.get kilometers per kilowatt hour. Doesn't match the one here, and my vehicle.get the max, and then we can assert if they all equal. Assert equals my expected and my actual. Nope, actual current here. There we go. Give the right ones. If you copy paste, so this is why it's nice to have different values, because sometimes you copy paste wrong, because I always copy paste things wrong. Oops, I should have more expected here, so that's all right. We'll fix that in a minute. Do they match the kilometers here? And the max kilowatts here. Okay, let's give that a try. Uh-oh, I'm missing, my method here. That's right, it needs some parentheses. That's why, that's a method. All right, and my test passed. So I have my classes here. I have the tests for them. Right, all the lines of code are running. So if I look at the rubric, I have the class, I have the tests. I have the class, I have the tests. I have the class, I have the tests. Life is good. All right, folks, if you have any questions or concerns, let me know. You take care.